Good morning everyone. Today we are going to discuss about the electron movement. What are the electron movements and what is the importance of the electron movement. So we are discussing the movement of electron in terms of the resonance, hyperconjugation, inductive effect and electromagnetic effect. When we talk about the stability of the compound, which one is stable, which one is unstable, we talk about the charge, we talk about the movement of electron. The movement of electron is actually responsible for the stability of the system or whatever the chemical properties is shown by the system. Actually, when you will see the fundamental particles, there are three fundamental particles, that is the electron, proton and neutron. And when you will talk about the position of these three particles, you will find that the proton and neutron is in the nucleus and electron is rotating around it. So it is not the neutron or proton which can determine the property of the system. It is only the electron which can determine the property of the system, and we are going to discuss about it. So how many type of the electron movements we are going to discuss here? The first type of electron movement is called the resonance, where the delocalization of pi electron takes place for the stability of the system. The next one is the hyperconjugation, which is also known as no bond resonance, and that is also a factor which stabilizes the compound, which stabilizes the carbocation generally. The next one is the inductive effect, which is responsible for the generation of the dipole moment, which is responsible to direct any chemical reaction to any specific direction. And last one is the electromagnetic effect, which is actually responsible for the chemical reactions. So we are going to start with the first one, that is the resonance. When we talk about the resonance, there are two different types of the resonance. The first one is called the positive resonance, where the delocalization of the negative charge is taking place. And the second one is called the negative resonance, where the delocalization of the positive charge is taking place. So we are going to start with the resonance, and in the resonance we are going to start with the positive resonance. So here we are starting with the positive resonance. First, which of the compound will give the positive resonance? We say that only those of the compounds can give the resonance which have the conjugation of pi electrons, that means pi, sigma, pi condition. Pehle pi, फिर sigma, फिर pi. If that condition is there, then that is in conjugation, and then that is only capable to undergo the resonance. Now, if the conjugation, in general term, if the conjugation of the benzene ring is with the negative charge or with the lone pair, generally those are the compound give the positive resonance. So here we are taking chlorobenzene. This is the chlorine containing three lone pairs. So the conjugation is in between pi, sigma, pi. That means the conjugation of benzene ring is with the electrons, that is the lone pair of electrons. Now, if the movement will take place, these are the electrons will move to the bond in between carbon and chlorine, in between benzene and chlorine. And after movement, what happens? The carbon chlorine double bond appears, and due to the loss of electron, chlorine gets positive charge. Now, this bond moves here on this carbon, and the bond changes in the form of the charge, and the charge appears on the position number 2, which is well known as the ortho position. Now in the next step, this one will move here forming the bond, and this bond will move here forming the charge. All the other bonds will remain same. Then this is the condition. The next one. In the first case, the charge was on the ortho position, and in the next case, the charge is on the para position. Whatever the arrow we are showing double-headed arrow. That means this compound can change in the form of this one, and this one can change in the form of this one. That means they are interchangeable. Now, if the next movement will take place, then what? The charge will move here, and the bond will move to the next carbon, that means here, and the remaining bonds will remain same, that is the Cl positive. In the next case, when again the next movement will take place, this charge will move here, forming a double bond, and this bond will move here, generating a single bond in between carbon and chlorine, and the neutralization of the charge. That means the lone pair will again remain on the same position. all the other bonds will remain there. Such type of the resonance is called the positive resonance. Here you can see the charge is appearing on the ortho, para and again on the ortho position. That is the 1, 4, 6, 2, 4, 6 position. That means the charge can't appear on these other two positions. That is the meta position. The charge can only appear on the ortho and para position. And here you can see it is the negative charge which is resonating. So when the negative charge resonance is taking place, the resonance is called the positive resonance. Now we are going to see the negative resonance. When we talked about the positive resonance, we said that those are the resonance in which the delocalization of negative charge is taking place, that is called the positive resonance. And where the delocalization of the positive charge is taking place, that will be called the negative resonance. What will be the condition? Surely the condition will remain same, that means the conjugation is necessary for the resonance. So if the system is in conjugation, the system will be capable to show the resonance. And in the previous case, the conjugation was needed in between benzene and the next carbon. That means the next element where the element may contain negative charge or the lone pair. मैंने आपको कहा कि बेंजीन के साथ जो अटैचमेंट है, अगर उसके पास नेगेटिव चार्ज हो या लोन पेयर हो तो वो पॉजिटिव रिजोनेंस देता है, लेकिन अगर कॉन्जुगेशन पाई पाई बॉन्ड के बीच में हो तो वो नेगेटिव रिजोनेंस देता है. सो यू कैन सी आई एम टेकिंग बेंजल डिहाइड है पाई सिग्मा पाई. And this pi is a pi bond, not a pi electron. That means the lone pair or negative charge is not there, so it will be a negative resonance. So in this negative resonance, the movement of electron will take place to the oxygen, and this will follow it. So it is double bond here, and this bond is negatively charged. And after losing the electron, this carbon will get a positive charge. All the other position will remain same. In the next step, the bond will shift here and it will form CHO negative. In the next step, the movement of the electron will take place and will form double bond CHO negative. And finally, the movement of electron will take place. One of the bond will move here, forming a double bond, and this negative charge will move here, generating double bond O. So here it is the negative resonance. In the case of negative resonance, you have studied that the pi sigma pi conjugation is there in between two pi bonds, one of the benzene ring and one of the attachment. And in the case of the negative resonance, it is the delocalization of electron taking place, but it is not the pi electron. So it is not the negative charge, it is the positive charge whose delocalization is taking place. So when the delocalization of the positive charge is taking place, it will be negative resonance, and when it will be negative charge, the resonance will be called positive resonance. The next electron movement is the hyperconjugation, which is well known as no bond resonance. That means during the resonance, the bond doesn't appear. We are not calling it resonance because this is not actually resonance, because the delocalization of the pi electron is not taking place. There is not any condition of the hyperconjugation, etc. So this is the hyperconjugation. This is called the hyperconjugate movement of the electron or the no bond resonance. In this condition, this is the positively charged carbon, carbocation, and the carbon next to this carbon, positively charged carbon, whatever the hydrogen is carrying, that means these are the hydrogen, जिनको मैंने circle कर दिया है, these are the hydrogens are called the hyperconjugate hydrogens, and these are the hyperconjugate hydrogens are responsible for the process of hyperconjugation. So see, for the process of stabilization of this positive charge, the movement of bond, the movement of electron from this hyperconjugate hydrogen take place, resulting the loss of bond, and when the loss of the bond will take place, loss of electron will take place, this hydrogen will gain a positive charge. And this carbon-carbon bond, which was initially single, after getting this electron, after getting the pair of electron, will form a double bond, and this will be the condition. That means the carbon-carbon double bond and hydrogen turns in the form of the hydrogen ion. Now, in the next step, when you will see, the movement of the next bond will take place. Actually होना तो ये चाहिए कि यहाँ पे हाइड्रोजन टूट के निकल के बाहर चला गया, लेकिन होता ये है कि निकल के बाहर जाए उससे पहले दूसरे बॉन्ड की शिफ्टिंग हो जाती है. सो यू कैन सी इट इज अ वेरी क्विक मूवमेंट ऑफ द इलेक्ट्रॉन. एंड आफ्टर दिस मूवमेंट व्हाट हैपेंस? Now this bond is formed in between carbon and hydrogen and this bond is broken, so the charge will move to the next hydrogen and here the system will remain same. In the next step this bond will move here and after movement it will form CH, H positive and double bond CH2. And the next step this bond will move here generating the parent. So in the whole process what happening, why this whole process is happening, you can see that the delocalization of the charge is taking place. This charge is moving here, here and here. That means the delocalization of charge is taking place. And delocalization of charge will generate the dispersion of charge. चार्ज एक पॉइंट पे ना रख के डिस्पर्स कर जाएगा. ये कुछ वैसी कंडीशन है कि अगर मैं इस चॉक को हाथ पे यूं दबाऊं तो मैं आसानी से इसके प्रेशर को फेस कर सकता हूं. लेकिन अगर मैं एक पॉइंटेड पेन को हाथ में चुभाऊं तो हो सकता है छेद करके अंदर घुस जाए. रीजन, ताकत मैंने सेम लगाई, लेकिन यहाँ पे चॉक का फेस ब्लंट होने की वजह से जितना भी मैंने ताकत लगाया, जो भी लगाया फोर्स, वो इतनी दूर में डिस्पर्स कर गया, जिसकी वजह से कम प्रेशर जनरेट हुआ. लेकिन पॉइंटेड पेन में क्या हुआ, एक पॉइंट पे सारा प्रेशर लगा जिसकी वजह से प्रेशर बहुत ज्यादा बढ़ गया. सिमिलरली इफ द चार्ज इज ऑन एनी स्पेसिफिक पॉइंट, the effect of that charge will be very heavy. But when the charge dispersion is taking place in the case of the hyperconjugation, the effect of charge becomes lesser and the stability of the molecule becomes greater. Then this is the way of the stabilization of the carbocation with the help of the hyperconjugation. तो यहाँ पे हमने देखा कि हाइपरकॉन्जुगेशन किस तरह से किसी कार्बोकैटायन की स्टेबिलिटी के लिए रिस्पॉन्सिबल है. यू कैन जस्ट नोट इट डाउन बाय पॉजिंग द वीडियो. Our next movement is the inductive effect. Inductive effect is not the complete movement of the electron from one bond to another bond. जैसा कि हम पहले देखते थे एक बॉन्ड से निकल के इलेक्ट्रॉन दूसरे बॉन्ड पे चला जाता है, ऐसा कुछ भी इंडक्टिव इफेक्ट के केस में नहीं होता. Actually, the inductive effect is generated only in the case when और respectively electropositive system is attached with the respectively electronegative system. जब एक respectively electropositive system को respectively electronegative system के साथ अटैच करते हैं, then whatever the effect is arising, that is called the inductive effect. अब यहाँ पे अगर ऐसा है कि ये देखिए मेथिल ग्रुप क्लोरीन के साथ अटैच है, कार्बन respectively electropositive, क्लोरीन respectively electronegative. So the movement of electron takes place from electropositive to electronegative elements. Last year, in the previous book आपने पढ़ा था with the name of the dipole moment. So the dipole moment takes place, and as a result, this chlorine works as an electron withdrawing group, and as a result, the partial negative charge appears on the chlorine, and this carbon works as an electron donating group and gets a positive charge over it. Then this such movement of the electron is called the inductive effect. This electron donating nature of the system is called plus I effect, and this electron withdrawing nature of the system is called minus I effect. So electron donating tendency is the plus I effect and electron withdrawing tendency is the minus I effect. So this is the next electron movement. For today it's enough. In the next video we will discuss the next topic. Till then, bye. Have a nice day.